Discovery alert! Around 170 rogue planets discovered near us. Did you know that according to a recent study, we found up to 170 free-floating or rogue planets? The interesting thing is that they are located in the local neighborhood. In fact, they have been found in the part of the sky between the Scorpius and the Ophiuchus constellations. What does this mean? And what are rogue planets? Also, the important news is that if they're not rogue planets, they're possibly brown dwarfs. Have you ever heard about brown dwarfs? Keep watching the video. We will dive into the world of mysterious wandering planets and cold stars. In order to understand the discovery behind this new amazing study, we need to explain what is infrared light. Indeed, if we didn't know about the existence of infrared light, we could have never observed these objects. It's also called infrared radiation, and it's a type of radiant energy that's visible to human eyes, but that we can feel as heat. All objects in the universe emit some level of IR radiation, but two of the most obvious sources are the sun and fire. IR is a continuum of frequencies produced when atoms absorb and then release energy. From highest to lowest frequency, electromagnetic radiation includes gamma rays, X-rays, ultraviolet radiation, visible light, infrared radiation, microwaves, and radio waves. Together, these types of radiation make up the electromagnetic spectrum. British astronomer William Herschel discovered infrared light in 1800. In an experiment to measure the difference in temperature between the colors in the visible spectrum, he placed thermometers in the path of light within each other of the visible spectrum. He observed an increase in temperature from blue to red, and he found an even warmer temperature measurement just beyond the red end of the visible spectrum. Did you know that infrared radiation emitted from our bodies is used to measure our temperature? Every object that is not in absolute zero temperature has atoms moving within it. This speed of movement is in direct correlation with its temperature. The higher the temperature, the faster will be the movement of molecules. These moving molecules emit energy in the form of infrared radiation. The wavelength of this radiation is longer than those of visible light, hence we are not able to see it with the naked eye. However, the radiation can jump to the visible spectrum if the object gets too hot. A hot metal glowing red or sometimes even white is one of the examples. While we may not be able to see infrared radiation, we can still sense it in the form of heat. The heat that we feel from sunlight, a radiator, or a fire are all examples of infrared radiation. It is this heat that the infrared thermometers detect to measure the temperature of objects. The rogue objects don't emit visible light, therefore they must be tracked with infrared light. Now that we know what infrared light is, we can start talking about rogue planets. A rogue planet is a really unusual object because we are used to thinking about planets as orbiting around a star, the so-called host star. In fact, the official definition says a planet must orbit a star. Rogue planets don't meet this definition, which was decided on by the International Astronomical Union, the IAU. The IAU is the group that decides on official definitions and names for things in space. They are also the same people who decided that Pluto is not a planet. Rogue planets are free-floating planets, which are not bounded to any star and are not orbiting in circular orbits around a center of mass. That's exactly the reason why they are also called FFP, which stands for free-floating planets. Nowadays, we have a lot of methods at our disposal that we can use to find planets orbiting around other stars. Astronomers do this on a daily basis, looking for planets like ours, the so-called exoplanets. These methods, of course, won't work for the orphan planets. They also only emit light in the infrared domain. However, another method of detection could be the following. Rogue planets alter the light from stars that are much farther away. The process is known as gravitational lensing. If something in space passes between Earth and a star, the object's gravity focuses light from that star onto Earth. It's like having a magnifying glass. To someone on Earth, the star brightens as the object passes by, and that's how researchers discovered some tiny rogue planets as well. Nowadays, we know that rogue planets exist, but actually it's only recently that the idea of huge numbers of rogue planets roaming the galaxy has been accepted as accurate. The idea of a rogue planet has been around in science fiction for about a century. The fact, meanwhile, has gotten people fascinated and diligently mapping things. Therefore, of course, things instantly got a lot more complicated. The original theory of rogue planets was that they were slingshot out of our parent systems. But this theory can't hold. Why? It's a matter of numbers. The problem is that we found so many of these planets, and probably billions of them exist in the universe. The firing out of these planets requires a bit too much gravity and coincidence. So the new theory is that they form independently through some unknown process. That's the beauty of the word unknown. You don't have to commit to any theory but honest ignorance. But now let's dive into the discovery itself. We could be facing the largest group of rogue planets discovered at once, 170 of them. As per the astronomers and researchers involved in the discovery, these giant planets are in a star-forming region relatively close to our Sun in the southern constellations of Upper Scorpius and Ophiuchus. It is assumed that billions of such planets float around the Milky Way. The first author of this study is Nouria Miret-Roig, an astronomer at the Laboratoire d'Astrophysique de Bordeaux, France, and the University of Vienna, Austria. Miret-Roig said, "We did not know how many to expect and are excited to have found so many. How is it possible to find so many planets all at once? Because sacrifice always pays you back." The team worked through about 20 years of data from various telescopes, including the European Southern Observatory facilities. We measured the tiny motions, the colors, and the luminosities of tens of millions of sources in a large area of the sky, said Miret-Roig. These measurements allowed us to securely identify the faintest objects in this region, the rogue planets. Rogue planets are elusive. Their masses are similar to planets in our solar system, but without a star to orbit. Rogue planets are exceedingly hard to spot. Per the ESO news release, the team used observational data from the ESO's Very Large Telescope, VLT, the Visible and Infrared Survey Telescope for Astronomy, VISTA, the VLT Survey Telescope, VST, and the MPG ESO 2.2-meter telescope in Chile. The vast majority of the data comes from ESO observatories, which were absolutely critical for this study. Those telescopes are the best ones we currently have on Earth. For example, ESO's Very Large Telescope, VLT, is a flagship facility for European ground-based astronomy. It's one of the world's most advanced optical telescopes, consisting of 4-unit telescopes with main mirrors of 8.2 meters in diameter. Can you imagine it? The telescopes can work together to form a giant interferometer, the ESO Very Large Telescope Interferometer, allowing astronomers to pick up much finer details of the cosmos than would be possible with the ATs or the UTs alone. The 8.2-meter diameter unit telescopes can also be used individually. With one such telescope, images of celestial objects as faint as magnitude 30 can be obtained in a 1-hour exposure. This corresponds to seeing objects that are 4,000 million times fainter than what can be seen with the unaided eye. The large telescopes are named Antu, Kia, Melipol, and Yepon. Astronomers behind this discovery said they used tens of thousands of wide-field images from ESO facilities, corresponding to hundreds of hours of observations, and literally tens of terabytes of data. The team also used data from the Gaia satellite, which is a space-based telescope. By studying the newly located rogue planets, astronomers hope to learn more about planet formation. Currently, there are 2 primary theories about rogue planet formation. Some people believe that the planets form from a gas cloud collapsing that was too small to form a star. Others think that rogue planets may be planets that somehow got away from a parent system. The team's paper outlines that they found an excess of rogue planets up to a factor of 7, which suggests that other formation mechanisms may be at play, and also adds credibility to the planetary system ejection theory. Therefore, the study of rogue planets is very important if we want to better understand the universe and develop accurate models which can predict planet formation. What if these planets turned out to be brown dwarfs? In fact, this could be a possibility because it's hard to distinguish between rogue planets and brown dwarf stars because they are cool stars that emit in the infrared domain. Brown dwarfs lie between the definitions of planets and of stars. They are between 13 and 80 times more massive than Jupiter and are therefore massive enough to fuse deuterium, but not hydrogen. In comparison, the Sun is about 1,000 times more massive than Jupiter. Although brown dwarfs produce their own heat and energy, they shine less brightly than stars, which makes them difficult to observe. Luckily, the James Webb Space Telescope launched on December 25, 2021. Infrared light is exactly the type of light the James Webb Telescope has been made to observe. Instruments on board Webb also have specific models of observation that make it the perfect tool to study these mysterious objects. Only time will tell us how many amazing discoveries we are about to make. We just have to wait and keep it curious. That's all for this video. Thanks for watching, everyone. Did you know about the existence of rogue planets? What do you think about brown dwarfs? Let us know in the comments below. See you next time on the channel.